assuming Crystal has done, I'm not sure if she's done EGMO 3 or not, but she probably will. She can. I mean, the first 8 minutes she probably can just watch on her own. I think it's more the end that she'll be interested in anyway. Okay, so for EGMO 3, okay, what was the question? What was even the question? So this was a nice question in the sense that I think there's lots to do. You're never really not doing anything, and it was the gold medal question. So let me just explain what the question was.
It's gold medal. This isn't an even time question.
It is a non-even.
So you start with A1 is a square, yeah? And then you construct this sequence where like n A1 plus n minus 1 A2 until, so you construct it recursively until you get, wait, is it 2? Is it?
The wording of the question was really weird.
Yeah.
I mean,
And then this is the minimum such that this whole thing is a square, yeah?
It's a while to figure
Yeah.
out what they were talking about.
Okay, and the question was to prove that this sequence eventually is constant. Yeah. So show that there exists a k such that what was it? That an equals ak for all n greater than or equal to k. Yeah. Something like this.
Yeah.
Okay. This was the gold medal question because if you could solve this question, assuming you solved all the easier questions, so like 1, 2, 4, 5, if you solve this question, you'd get a gold medal in this EGMO. And actually, you wouldn't even have to solve it. I think if you just came up with your observations, you would get the gold medal because the gold medal cutoff was like 3 points above 4 questions. That's what I meant before. Yeah.
That's pretty good.
Yeah. So, yeah. So. Okay. The bad thing about this question is I think you can actually solve it very quickly if you kind of just if you saw that idea first. Like,
Is that random gaming?
so that's a bad thing for it's too much variance in the results if you do that. So there'll be people that like will solve the question just because they saw it differently at the start, and it'll be really quick. So it's
that was me.
So it's,
Yeah, well, me basically. Yeah, we failed that.
Okay, and
I could have just done it like, but I did one.
Okay, so I was actually also saying it's like it never exists in reality where like you just give people the idea and you tell them to write the proof or finish it off themselves, right? But then I think this is what I'm gonna do. So that's what this exercise is. So it's so I kind of want to recount the problem solving process for this problem, and then maybe as a group fill in the proof writing part, if not all the other parts. Yeah. Okay. So I can tell you this question took me less than 9 hours. I can't tell you how long it took because at my age you never really get a continuous block of time to work on this. So I started at 1 o'clock and then like stuff happened during the day. Send the kids to school. Like, I don't know, like, and then pick them up. Yeah.
I think that's what Terrence tells
Bro,
me.
that's like, what's it called?
He was doing some
SA6.
reason I wrote question said it took me 9 hours, but I was doing other stuff.
Takes 2 weeks to solve. SA6 2 weeks to solve.
Okay, so for this kind of problem, my go-to process is to just basically do the cases until I come up with something. Okay. So I would do cases until I die. If I don't come up with anything, I just keep going. Okay. So you can try like. So I have the rough wording
I
here.
should have just came up with cases until
I guess the
I
sequence
died.
uniquely determined, so you can. There's pretty much only one.
I stopped
Yeah.
at 7
There's no-
and then I.
So if you start with one.
The whole sequence is determined.
Yeah.
Yeah. Starting number.
So there's some things I'm gonna skip unless you really want to see it. Okay. So for example, the first one I think it just repeats at 2, right?
Yeah.
You remember doing this?
Yeah.
If someone didn't do this and still didn't do this and didn't solve it, it's kind of weird, right? Maybe Yasser didn't do it and solved it.
Oh no, actually, I actually did. I just
Don't follow his example. He's not really doing maths. That's what I was trying to say here.
How is
this time I did the small cases.
Oh,
That's why he
after,
sold
like
it.
one look. the
Okay, so
question
do these
was-
make sense so far?
Yeah.
9, 7,
It just bounces up and down.
Yeah, so I guess you're not just blindly doing the cases. You're always looking for opportunities to find something, right? Make like conjectures, disprove things, prove things. So one thing about this that's really obvious at the start is it's really easy to prove that this is true, right? So once you know it's two even once, you know it repeats it two as well. So this can be proved easily, yeah. Okay, then you're looking and you're looking, you're noticing maybe the squares that repeat. The terms in the sequence that are repeating are all even. That the even square is of the form like 4, 1, 2. Yeah, you know, if something's a double of a square, it's also the half of a square. It's these things.
That's a 500. Wait. Oh my god.
I don't see the rub, but it's okay.
They are also 1/18.
I don't either. Oh my god, you absolute genius.
Okay, so
I just had a revelation.
I'm getting flashbacks to
okay, and then like it's kind of very difficult. Like even if you're doing this, you're trying to like maybe like it's very easy when you know the terms. But what if you like remove the 4 and the 1 and you just had the 2? Could you figure out that it should be a 4 and a 1? So that kind of stuff I was trying. It was not very successful. Just kept going.
SPD. This show.
What SPDF?
No, not SPDF. No,
What about SPP?
SPDF.
Let's go with
This number of electrons in the show. Oh.
Okay, so huh?
It's fine, don't worry.
Okay, so the first
9P7,
the first
2/18.
the first truly meaningful observation that wasn't really used immediately was I think a lot of you guys already came up with it, was that the sequence, the squares, was like a square, right? And then you're plussing the sum of all the terms
Yeah.
Oh, yes.
to get the next square, yeah? So that was like the first kind of thing you're like, oh, this is neat. Interesting. I don't know how to use this, okay?
That's basically just how I calculated.
Maybe we'll figure out we had the same experience of this problem somehow.
Magic.
Yeah, that's just how I did all the cases. Just did a big table with the sum and the.
Okay, so I guess you're slowing down because
I think it's at this point you realize that what the problem proposer was thinking.
You have to read the mind of the problem.
I think when I got to this time, I realized, oh wait, that's it. That's the reason why they made this question.
I was just like, I see.
I can't remember what 36 was, but it was probably like, wait, it was not 9. What was 36?
Look at my
36.
my.
I had it somewhere.
13.
13.
Wait, no, not 13. 72.
36, 9, 18.
36.
9, 18.
36.
9,
Yeah.
18.
Yeah.
You know, you might have a conjecture like, is it always repeating at the third spot? Okay.
No.
Yeah, we disproved that.
Yeah, so you're gonna disprove it by like going
Doing
down
this-
more sequences
doing
or
the next
imagining.
one. Dude, doing the next one. I didn't do the next one.
Wait, are you saying this one doesn't work?
61, 28.
Wait, isn't this one
square.
32? Is it this one?
Wait.
No.
It doesn't
It
repeat?
is in your
It
head.
repeats on the fourth term. 16,
Oh.
4, 16, 1, 8.
Yeah, 16, not 12.
Wait, does this not repeat here?
Yeah.
Oh,
16, 1, 18.
I think I just assumed it repeated.
How do you do this in your head? See.
Yeah, that's why you don't assume.
Is this 32
You
repeating?
assume you make
That's
it
why we
pass.
did 69 squared. Try it.
125.
And then it had 10 times.
I think I checked some of these. I didn't check all of them, but I was kind of thinking about something else while I was doing it. Basically, it was related to this. I was thinking about sort of like, is it always well? I kind of figured out why it wasn't going to repeat on 3, because like you know like if you have like 4k squared, or maybe not km, you have m squared. So 2m squared will make a square, but sometimes you don't have to have 4 like 2m all squared. You have like 2m minus 1 all squared, right? And so that's not going to work all the time. And then I guess the thing I was really looking for consciously, subconsciously I was looking for anything, right? Consciously I was looking for like some weaker statement, something weaker than the actual problem that was apparent and I could prove it, right?
Yeah.
and I was, or maybe something very specifically stronger than this problem. So something very specific that was strong, or anything that was weaker. Okay.
Wait, why?
Huh?
Why is this the approach?
Because when something is really specific, there's not many ways to prove it when you're like definition chasing, right? It's like you have like it's like if the theorem happens to be it's like it always repeats on the third term, the second term is always twice the first term. Like that should be easy to prove. Okay, but if it's not very specific, like the statement of this problem, then it might be difficult to prove. But if it's weaker, then it might be easier to prove. So there was this one moment.
A weaker statement is easier for a robot to prove, but harder for human to prove.
So I guess the key is to find the right weaker statement if it exists. You know, so at some point it really came to me. The one moment where I realized something was going on was this moment where I was kind of saying the sequence is bounded. Okay, so that was the statement I found, the weaker statement. So if something's eventually constant, it has to be bounded, right? Okay. So I think I actually proved this incorrectly, because but it led me to the right idea. So the
So how do you get the idea to bound?
So the idea I got from is bounded. It came from actually this case here. So you have this m squared, 4m squared, right? 2m squared. Oh, sorry, m squared and then 2m squared, right? It came from basically this idea. So even if you didn't have an even number, if you just start with m squared, right? The next number. No, maybe I'll do this example first. So the way this works is you get like 4m squared, right? And then if you're adding on all this again, right? So that idea is starting to be useful. You're kind of adding so wait, this is the first term, yeah. This is the second term. Yeah, okay. So then when you have 2 times 8, this 8 and 1, you get 9m squared, right? Sorry. Yeah.
Yeah.
Yeah, 9m squared. And then when you add, you're adding the 4 and the 1 again, right? So you get 14m squared. And so then if you add another 2, it'll be 16m squared, right? So in some sense it's bounded because in some sense it feels like it should be bounded because the 2m squared is getting to a square that's going to be the biggest it can get, right? Because it's meant to be sort of the next smallest square, but 16m squared is a square, right? So either it reaches that, it can't go further because it shouldn't get to the next square. So either reaches that or doesn't quite get there. So it should be bounded by 2m squared. Okay.
I'm so confused.
Alright, so
Does that make sense?
Like, even if you're not the smallest square, right? It's still like just can't go past it. It's like,
Okay, so yeah, there's a question here. So like, while that argument kind of works nice heuristically, can you see why it's not actually true or rigorous? Like it's true because you know it's bounded.
That doesn't
But,
sound right.
But why is it not
this
rigorous?
is not necessarily the smallest square, like weird stuff.
2m squared is not necessarily the smallest, right?
No, I'm saying I'm saying if you add 2m squared, you'll get so like if it's adding up to 14m squared, right? Then the next term will get it to add to 16m squared or less, right? Right?
Yes.
Because you're trying to sort of take this is defined to be the smallest number that gives you a square, yeah. So it shouldn't exceed 2m squared, yeah. So can you tell me why this is not a proof that it's bounded?
Like,
What about the stuff
m
after?
squared.
because if you do this at every
First
step,
term
it'll
A
make it
0
easy
or
to
A1.
get results.
Wait, it's A1.
So do you understand what my argument is? So tell me. So I'll explain it again. You can tell me why it doesn't work, okay? But the thing I'm trying to get to you is like arguments that don't work doesn't have to be discarded, okay? The idea still helps.
4m squared is second term.
So the first squared is 4m squared, yeah? First term, yeah?
No, first.
Let's assume the second term is m squared, yeah? Okay.
Alright, yeah.
Okay, and then the third term, so at the moment, like 2 times that is 8m squared, right? And you need to plus something to make it a square. So let's say it's m squared, right? You get 9m squared.
Oh, because
Yeah, and then
because
to get the next term, you have to add those two again, right?
Because that could be lower, and then it forces the next
Which
one to
which
be
gives
higher.
you
Oh,
so
yeah,
it's
true.
Well, Lucas, that
and
sounds right.
It could be less than m squared, and then the next one.
yeah, okay. So Lucas has it. So basically, it's not rigorous because this is this could be so say this is m squared and this is less than 2m squared, right? Then the other one could be more than 2m squared to still get to 16m squared because this one hasn't made its ground.
Ah.
But if you think about it a bit more, there's probably some squares in between that save you from that as well, right? Okay, so it's not completely rigorous, but it's enough to kind of give you this idea. It's actually a very central idea of the problem because what that means is like if that was bounded to m squared, right, and you're adding the sum every time, then it means that the square gap can only it can't increase by more than 2m squared every time. Okay, so this is the first moment where I was like, okay, I've solved like half this problem, or like this like whatever however long this problem is, I'm at the first milestone point. Okay,
If you say so.
if I say so, yeah.
You say so.
Yeah, and then I gave up. Yeah, so that's the end of the.
now we continue. This is where we come.
Now we keep going.
Yes,
Yeah.
we continue this.
For the next generation.
Yeah.
Until we die, we got this.
Pass your problems on to the next generation. They'll figure it out.
That sounds like a.
That sounds like
That sounds
something.
vaguely political. The undertones of you.
Okay, so then I was thinking, so I'm up to like, wait, what am I up to at this point? There's like 15 squared,
Mine, I wasn't
34,
working out.
41, 5, 50 repeater. Did you guys get up that far?
I think I might have.
Yeah, so I have this thing where it's like
Yeah, I
if
think
you
it's
haven't done enough cases,
Oh, no,
you
not
don't
that-
qualify to fail.
It's
Like,
not that bad.
you're not qualified to
it's that
fail.
bad.
You can't claim you give up or like
I think
you
I did
haven't
like
solved it.
16 or
I've
17.
done 100 cases.
Yeah,
Top 10.
yeah. It's like leaving it all on the court. Like what does that mean? How do you fail a problem with no regrets? It's get up to the 100th case. Yeah. Okay, so we keep doing this. So you can see now it's already more than 3, right?
Yeah.
Wait, just maybe it's Crystal messaging. Oh, sing.
It's sing. Amazing.
Hope.
Amazing music.
Amazing.
Oh, your mom says to check your texts if you get a chance.
15 squared, 34, 41, 5, and 50.
Amazing.
190.
Wait. Oh no, this killed my arm. What am I doing now? Like, you remember what's
I don't have an idea. I don't have an idea.
continued fractions?
What's an idea?
How's your idea?
Two ideas make
Alright, so you already see it's starting to, and other conjectures you might have along the way. It's like, does that sequence always decrease, or it starts to? It's not the case, right? Or like, what happens if it goes lower and stuff? So you keep going, and so at the moment now it's just like maybe my subconscious is processing what does it mean for this, the gap between squares to be bounded, right? And I think I had a good way of expressing it. So, and I think another thing is you can do it as you're doing the examples to test these things. And if the example is getting too big, you can go back to some of the previous examples, and you can compare the difference between having the idea and not having the idea. And that's really kind of the value of the idea acting on the example. Okay, so one thing I think, one nice way maybe to express it was, maybe we can do it through a big example. What is it?
How many times?
17, I think.
Pretty sure 69 was 10.
17. So you have 17 squared, right? I guess the way I was trying to think about it was, so 289. Okay, so 289. What's the next square? Like 324?
Why are we going
Don't you times by 2?
Yes, you times it by 2, yes.
You get 578.
578. And then 625.
What's 24? 24. What's 24?
576.
Wait, there might be 580 something. Wait,
I think it's 576 is a square, right? 24 squared.
yeah, okay, it's 625. What? 24. Oh shit, I forgot.
24 squared, yeah. Alright, so okay. So then 25 squared is 625, right? So that's like 47. So after 17 squared, you get 40.
No, it's too deep to be a small case.
Try small cases.
Okay.
The cases.
Bust out the calculator.
Oh, I want a case with cases.
Oh,
Try small cases with actual cases. Yes.
I feel like I didn't even necessarily do the right number here, but it doesn't matter because so one thing I would say, if you have the right, like the right idea is impervious to small mistakes. Okay, is it actually 47?
I don't know. Get my laptop.
Yeah.
So this
Oh
is
my god, it reaches a perfect
small
square.
case.
What?
And it's small
wait, is it 47?
Yeah.
Wait, after 47, it just reaches a perfect square. What the?
What do you mean after?
But like, the next time, I think you need.
Okay, so if you add 47, so it goes 17 squared. So I'm trying to keep track of the sequence of squares. So the next square is 25 squared. Sorry,
Yeah.
25 squared. Yeah. Okay, so here is a cool way to realize this thing. So you notice that the difference between 17 squared and 25 squared is like 8. It's like you go up by 8. Okay.
Ooh.
Right? And how you did that, okay, how you did that was you added so you have 17 squared, right? And then you added 17 squared again plus a mystery number, yeah?
Yes.
Okay. So that gives you a difference of 8 in some sense, yeah? And then to get the next square, right? You're doing the same thing again, right? The same mystery number of the 17 plus another mystery number, right? Okay. So what's interesting is because you're doing the same thing here again, right? Yeah. And the square gaps are always increasing. You'll never get to the you'll never get to the 30 you never get to 33 squared.
Oh.
You see?
Oh.
You see what I'm saying here?
I don't understand.
So like you added to 17 squared something to get 25 squared, right? If you add the same thing again, you're not going to get to 33 squared. Yeah, that's kind of obvious, right? But it's actually very key as well.
Yeah.
Because
Interesting.
yeah, so what that means is whatever that number you're adding is also not going to be bigger than 33 squared. So this sequence is bounded by this sequence of squares, but maybe not absolutely bounded at the moment. It's just bounded by this sort of. So it's bounded by 17 squared, 25 squared, 33 squared. Yeah. Okay. Yeah, it's almost over. I guess maybe we could stop for a second, just really appreciate what's happening here.
I am a bit confused.
So do you understand what happened?
17 squared plus something plus. Then you turn that into something.
Yeah, because this thing here is going to be strictly less than 33 squared, right? When you add up all that stuff. Because the difference between 33 squared and 25 squared is bigger than the difference between 25 squared and 17 squared.
Ooh. Wait, does that work?
Yes.
Oh, yeah.
Yes. Wow. So
Hang on.
the difference have increases.
The variables. So the mystery numbers are the sum of the A's. Yeah. Mystery
Yeah.
numbers. So each mystery number is at least the previous one. Is greater than the previous one.
Wait.
Okay, I guess maybe you have an internal check for like how much of the problem is solved at this point. No?
No, that's not right. What I say?
The mystery number is just the new A term.
Yeah.
I am.
No, wait, hang on.
It seems legit, but it's a bit sus.
Yeah, I mean, there's more to do, but like.
17 squared is the first term.
But can you see what the key here that allows you to solve the problem is? Can you kind of This is your observation.
25.
This is the proof of your
25
observation.
squared plus new mystery number. So that's the sum of.
Oh yeah, true. Wait.
So each. Wait. So the first mystery number is 8 2. Wait. 8 2.
Yeah. So again, I think the idea is the most important. Okay. So often people say, but proofwriting is important too. Okay. But proofwriting is necessary. Okay. So it only seems important when it's missing. Okay. But with this, so I want to kind of get the idea in all its glory, and then we'll try to do an exercise in proofwriting. But also, if we can finish the idea, can you finish the idea from here?
The mystery number, the sum plus
Yeah, sorry, I didn't write that out completely, but
the sum plus the extra thing.
yeah, so because you're always adding a1 plus an minus 1 plus an, right?
Yeah.
So this is what you added last time, right?
Ooh,
And then you're adding something else,
hold
right?
up.
So adding the same thing as last time is not going to give you the same gap as last time. That's kind of the key.
So I'm gonna give you the same.
Each mystery number is greater than the previous.
Yeah, the difference between squares that are the same number apart.
Yeah.
Is linearly increased.
I mean, I just like wrote them down by the side and just sort of like they were like getting they were like the
Yeah.
yeah.
So you can see like that's going to be worth it's going to be worth marks depending on sort of
Oh, yeah.
how they skew between
How to
like
do
the claim and the proof. But you can see this is quite a key idea, right?
Yeah.
So now you actually have a bounded sequence, right? Not necessarily bounded like absolutely, but bounded by the sequence of squares. So the sequence can be at most be 17, 25, 33, 39, or wait, 30, 41. Yeah.
Use the principle like make it go very, very big. And then
that's smart. Mistake.
the principle of extremely big.
no.
Okay, so you might be able to come up with some sort of hand wavy abstract argument to say you're done.
And
Okay.
maybe abstract.
But I think sometimes it's better to just see
Basically.
what happens more specifically, like because when something is specific, it's also easier to write in your proof. It's like it's hard to prove something without a definition. You know what I mean? And the definition is sort of what's going on here. Okay, so let's just do some more cases, yeah. So what happens? So 17 squared. So maybe we try to figure out at what point it becomes constant. Yeah. So also there's the question doesn't have to end with the exam time and the problem solved. It's kind of unlimited. You can prove stronger statements. You can play with it. You can do whatever you want.
Is there at what point does it have to be constant? Because there's some weird case where it just doesn't.
The difference.
Okay. So what was so we have 25 squared, right? Okay, 25 squared, and then what are we adding? We're adding 17 squared, right? Plus 41, 47. And then we're adding something else, right?
Next one. Oh, we can't add 0, right?
We can't add 0.
We can't add 0.
So
Doesn't
then,
it give you a square number?
Yeah, I'm pretty sure it's a square number. It's 31
What?
squared exactly.
really,
Yeah, 3 times 17 squared plus 2 times 47.
really,
Yeah, it gives you 31 squared on the dot. So you have to go with 32.
Yes.
I didn't even know that was possible.
Yes.
What? Oh yeah, next one is 1024.
It can randomly happen.
Oh.
39.
So you're saying this adds up to 31 squared?
Wait.
So what you're saying?
625. Yeah, I think so. 914. 961, yes.
961. Okay.
Looks like 33 squared.
Yeah, but I guess so then the AN will have to be
32 squared, so that's 39, 50, 63.
like 32 squared minus 31 squared.
63.
Interesting.
like peculiar.
Okay. So 32 minus 32 plus 31, yeah? That's the next one.
2 squares.
And then we get to 32 squared, right? Yeah, which is even less. So then the next one
Is less than 7.
is not gonna get you up to. It's not gonna get you to 39 squared.
Yeah.
Right.
Oh.
So it's gonna stop short at 39. Okay.
Stop short.
Right,
So
so
if this difference between
the argument is that
Yeah.
that makes sense.
So I think I had a nice way to write this out. So
So it's like
it's kind of based around the idea. So you have 20.
very suspicious.
So you're at 32 squared, right? Okay. And then you add. So you add the stuff you added before, right? And then you need a new mystery number. Yeah. Okay. So the stuff you added before was what you needed to get from 25 to 32, right? So it's a gap of 7 from 25. So you're really adding like 2 times 7 times 25. Does that make sense? Because 25 plus 7 squared, right?
Yeah.
Which is 25 squared plus 2 times 7 times 25 plus 7 squared, right? Plus 7 squared, and then there's a mystery number, yeah? So you're adding this part that you did again, right? So now you can kind of see what's going on, because like this has to be less than 39 squared, right?
Yes.
Okay. So what would this mystery number have to be to make it equal to 39 squared, right? It would have to be 2 times 7 times 7, right? So this kind of also proves that it's 2 times a square, see? So it'd have to be 2 times 7 squared to get you all the way up to 39 squared.
Oh, and once it reaches 39 squared, repeat.
Does that make sense?
Twice a square.
That looks like it would repeat.
So I guess, yeah. Okay, so what is fundamentally the problem here? Well, so why it might not be 2 times 7 squared, right? It might be less. Yeah, but it'll never be more. Okay, so in this sense, that does prove it's bounded now, doesn't it? Does it prove it's bounded now?
How?
So it's always less than 2 times 7 squared.
Oh yeah.
Yeah.
Yes.
It's kind of a checklist of things.
Look at this. The square root, the gap between the square roots is bounded.
Yeah.
I'm confused.
Yeah.
In every time, like
Yeah, this is a special welcome back to the term question where I do most of the work. Usually I just let people solve from some point on. Okay, so
that's why we're not on the floor today.
yeah, so we have 2 times. So this actually proves it's bounded. Okay, not that I actually noted that down at the time, but
Every time.
because that was something we were trying to prove before, right? Okay, now, so under what circumstances is it not going to be 2 times 7 squared? Okay, but the thing is, if it's less, if it's decreasing, right, it's still going to terminate, right?
Yeah.
It's just, I guess, maybe we're just investigating a little bit further.
Yeah, that makes sense.
So I guess the problem is it could be 38 squared, right? So if you look at 39 squared minus 38 squared, yeah, that's a nice easy calculation. It's 77.
What if it balances out?
Yeah. So the fundamental comparison is if 77 is bigger than 2 times 7 squared. Yeah. So if 77 is smaller than 2 times 7 squared, then that number there is lower than 38 squared, right? So it's only going to go up to 38 squared. If it's smaller, then it's going to go all the way up to 39 squared. Yeah. Okay.
It's gonna be
So you're always going to
You
be.
see what's happening here? So because this difference is
Which
77,
means that it has
which
to
is
be
smaller
16,
than
so-
2 times, which is 2 times 7 squared is about 100, right?
Yeah, okay.
So 77 is smaller than 100. It means this is not going to be 2 times 7 squared. It's going to be more like, so what's 38 squared? But it's going to be yeah, it's going to be, so it's going to be less by this difference here. So it's 98 is going to be like minus 77 is 22. So it's going to be 77, I think. Wait, sorry, that doesn't make sense. It's gonna be.
I did a sussy for so
What's it gonna be?
I kind of want.
Yeah, so I guess 98 more than this number is 38 squared, yeah? So x plus 98 is 39 squared, sorry. And then 39 squared minus 38 squared is equal to 77. Yeah, so this number is going to be 22, isn't it? So this number should be 22. So if you plus 98 to get 39 squared, but 38 squared is actually 77 less than 39 squared, you could have plus 22 to get to 38 squared, yeah? And you're unlikely to be able to plus less, yeah.
It is indeed bounded.
Okay, so now it's 38 squared. Okay. So can you see what happens at 38 squared? So 38 squared. Now the difference between 38 and 32 is 6, right? So what you're adding is 2 times 6 times
38. Wait, no.
the number before, yeah? 32, yeah? Plus 6 squared, yeah? And then plus some mystery number, which is your next term in the sequence. And it's going to be less than 44 squared, right?
That'll be 2 times 6 squared.
Oh.
Wait, the mystery number will be 6.
Is this how you did it?
I kind of just go straight to the algebra. I can't decimal case.
Oh, yeah, no, I can kinda
He guessed the write-up and then wrote it.
I kind of see how this will go.
Huh?
Like, you can,
Wait,
I
what
think I just,
happened?
I think I
What
just
happened?
pretty
I'll
much
answer the
guessed it
next.
correctly the first time.
Wait, why are we doing?
Oh, okay, so he's the reason why the
why are we
problem's not a
doing
great
this?
problem.
Wait,
wait, is it? Because
What?
if that
I'm the
square keeps
reason-
repeating, it's like 44
There's
goes
like
to
3
50
parts of the
and
question.
56 and
Yeah.
stuff,
3
then
parts are right.
you'll just be adding
I'm
2
pretty
times
sure.
6 squared.
I guess I know
Yeah, so
what this
so
is.
if
Oh, that's why it's 2 times 6.
so if you're gonna get to 44 squared, right? Then this is gonna be less than 2 times 6 squared, yeah. So, and the question is, how do you know if it's gonna get there or not, right? You look at the square below it.
He sees this. I don't
Yeah.
see it because it's actual math.
Oh, sorry,
I don't know
it
how
couldn't
to
be
do
77
actual
again. It's
Oh.
87.
Right, how would you write this up?
Okay, so it's 80. Could you understand what's
You
going
prove
on
the
now?
squares are bounded by a certain amount, then you need to prove this.
So 87 is that
Yeah.
bigger than
The
2
sequence
times
are therefore
32?
bounded by
6,
some amount.
36.
And then you need to prove
Yeah.
that because they're bounded,
is, right?
they can't repeat.
So what does that mean?
On something.
So this is 72. So 87 is now bigger than 72, right?
So it's screwed?
So what does that mean?
It's screwed?
Wait a minute.
Are we screwed?
Ah.
So before we had that it was bigger, the other way was bigger. Now it's smaller, right? So now this 2 times 6 squared being 72 is smaller than the difference between 44 squared and the previous square. What does that mean?
Wait,
Does that mean it is 40?
Yeah.
it is.
Doesn't mean.
Hold on. What? The hell?
Wait.
Wait a
Let's see
minute.
what depth. Pixel mode.
Small.
I think I proved something I didn't need to prove, and maybe I did.
In EGMO.
And yeah.
I proved something I didn't need to prove and didn't prove something I needed to think so.
Necessities.
But then it's weird because I'm not sure the thing I I unnecessarily proved his truth.
Okay, so my question is, what does it mean now that it's
that was-
smaller than the gap? Okay.
Whoa. If it's smaller than the wait.
If you can answer. Oh, who's here?
Is that Leo
Or
or
Leo Crystal.
Oh,
We have a square that's smaller than
Crystal's
the
here.
bound.
quite big.
Leo probably won't be that.
That's me.
Yeah.
Yeah, I'm curious if he rocks up the T3 meeting though. I think he will.
Yeah.
Crystal.
Yes, because
Crystal, can you hear me?
there are the questions in the handout. There's like US ATSTs.
I'll choose
US EGMO.
No.
Oh, okay, so Crystal, we're doing EGMO question 3.
I'm SLG fans. I don't
And,
understand why Chris is just
We have a new student, Inez. I don't know if you know her. Inez.
I bumped
Yeah, so say hi to Inez.
AFK.
Instantly.
AFK.
Have you done EGMO 3 yet? Have you had a look at it?
Absolutely.
Oh, she says hi. Okay.
Oh, hi.
Okay, so at the moment, okay, I'll summarize what we did right after this step. But can people tell me what happens when 72 now is smaller than 80?
It's smaller.
But does that mean we
Well, I think the bounce still
I think we have to
can be the same.
Yeah, so like,
I know.
so basically, even if you add 0, right, you're gonna be over 43 squared. That's basically what that
Oh,
means.
right, yeah.
Yeah.
So you have to go to 44 squared. So you have to come 6 squared.
I feel like this is
Yeah. So can you see now that if this number is smaller, right, then this has to be the number, and it has to end up at that square.
Yeah.
Yeah.
Oh,
Yeah.
yeah.
And do you see how why that idea works? Because
I feel like I'm in a different mental space.
yes.
Same.
yeah, I mean, I did present this a bit more spoilerish than usual.
Wait, more.
And Yasser is like,
Yasser
is also in the same one.
This was all the
Yasser is
already.
confused.
I
He's
stopped
used
laying
to spoil-
attention
he's
because
accustomed
these
to
cases.
spoiling.
Cases above 11, that's illegal.
Okay, let's mean I don't
I
consider this a
did 1, 2,
spoiler.
3. I did 1 square, 2 square, 3 square, 11 square, and then it's like anything above that, it's
So
too
this
hard.
is it's like hieroglyphics writing small cases.
Oh, wait.
Alright, so does anyone see how it works in general now?
Yeah.
And that's the annoying thing is that
Oh.
when you write
I
working
am
like this,
really
only you're,
confused.
I think when you write working like this, only the
not
writer
the-
can understand what they've written. So someone else will read it.
No, I think Will is proof that someone other than the writer is
Wait,
understanding.
can you zoom out so that like? you
Okay,
can see
who
it?
understands what I've written?
Now, if you're reading someone's work and you just see
I
this
feel like
page,
I partially understand the idea,
Right.
but
I think
I
I feel
don't
like this
really
is-
understand
Then
what
you
the
need
hell
to
you're
go. Surely you could just say, like, the gap between them 6 is like balance can only decrease. It can't increase. So like, either you stay constant or you just go down to 1. And then
Yeah, and then at some point,
Ah, yeah.
this number
yeah,
will always be smaller than this number.
yeah.
And this number is very obvious what it should be. It's the square. It's obviously getting bigger because it's
Yeah.
twice the square root of
So
whatever
the
the square.
square is less than desired, then it just continues square.
So showing like, at some point this exceeds like.
Okay, let's summarize the idea. If we can come up with a proof right up quickly, we can look at the official solutions too. If we want. If we have
Oh
time.
wait, it makes.
Okay, we're
hold
doing
on.
right
Okay.
now.
I don't know.
So basically, the idea is, you're adding. So if you look at the sequence of squares that defines the sequence,
Yeah.
the increase of the sort of the square root, if you will, is decreasing, right?
The increase
So,
of the
sorry.
square root.
So in this example, for example, we have like
Holy shit,
25
I don't
squared
It
understand.
can't, just say cannot increase, I feel like.
Plus- plus something gives you 30. We got 32 squared. Is that right?
Yes.
Okay. And then what we're doing is we're plussing the same thing again, right? Plus an extra term, yeah. And because the thing we added only got to 32 squared, this is never going to get you above 39 squared, right?
Yeah.
Okay. And so that gap is always decreasing,
Oh,
and that's probably enough to solve the problem. But if you want to be more specific, I think it's more.
I just realized my unnecessary thing is false. My proof, I think it still works because my unnecessary thing actually claimed that the square roots go up by 1, but it actually isn't true. But it's not,
So from there, if you prove it close to the same thing twice,
And if you write this difference,
if the same increment, if
Yeah,
you
if
get
you
the
increment
increment,
twice, that means this is less than that,
am I fake?
Yeah.
and then you're just done because you just keep.
Wait, this is a good
What?
Yeah.
I know my
or
fake.
it's like it's
I
the
see.
distance from like the next.
I
step.
see.
Yeah, it's
So
too big. Yeah,
the gaps
it's
between the
yeah.
square
And
roots are
and
always
then it like
Yeah.
goes
constant
farther
for
away
each
from the
thing.
bottom.
It doesn't
and
find-
therefore
Yeah.
the number is always constant. Or
Yeah,
so-
actually,
Yes.
my
So-
false proof was that I falsely proved that the square root gap goes down to 1.
Yes.
yeah. So I would just end it there or before there. But maybe we could try to get an idea for a write up as well.
Yes.
But can you see the solution is like it's almost a write up.
sounds
basically-
legit, but I don't know if it's
No, no. It's
Basically,
pretty legit.
I think you just
I mean,
like the main ones are just like defining another sequence, which is basically
like the sum of the
I think
terms.
it's
yeah the sum of
Just
the
replace
terms.
the
and
numbers
you
in
also have
algebra.
like the
Use
square.
B, the letter B.
So let
Yeah, like if you define a B such that B ends, you put an A1 plus A2 plus A0 plus A1.
yeah
Oh yeah.
yeah, and then that's the and then from there you can just do all the designs.
And
Finding the sequence.
Pretty nice.
Like,
what's my
You're right.
The hardest part is having the willpower to just write it up. I feel like that's
the sum
the
of
willpower to.
yeah,
Is-
it's yeah.
This is
That's so confusing though.
Yeah, so I guess one good thing about the gold medal cutoff is like you could probably just sketch a solution and you get over the cutoff provided you got full marks for the first 4 questions.
But you wouldn't know question 5 and 6.
Yeah.
Oh no, for 4 and 5.
Yeah, you wouldn't know 4 and 5 yet because you're still in day 1.
Got full marks 1, 2, 3, 4, 5. That's like wait no. Yes.
Gold medal.
No, that's
plus gold medal plus.
I
I'm
think
pretty sure
okay,
that's
and then if
higher
you think
than
about the
anyone in this
stats, the stats for Australia.
Yeah. because
32 was the highest, I think.
Wait, the
Three,
stats for
four.
Australia was only like one person solved this or 2 people solved this.
Oh, Jung.
So 2 people solved it from Australia.
Yeah, honestly.
Oh, we were
Ansu
29.
someone else.
29.
Oh wait, does it count if you get 6? Wait, did they get?
No, Ansu got
No one
7 for 7.
No one's not
Yeah.
playing 6.
No, but
Wait,
six,
no, when
six
did
is
this
good
got
enough.
marked? Everyone was like, oh my god, 42.
That's right.
It's like,
Yeah.
the first 2
I don't-
questions,
I don't
21
know.
out of 42. Oh,
This,
destiny. Yeah,
Like-
but EGMO perfect
like,
score.
honestly, this was so much easier than 6.
You
It's
said
It's
it
like
was about 4 weeks ago and now it's good.
I know it's really polarizing. Apparently, it's really polarizing.
Because we haven't done it yet. No, I'm just kidding. All right, fine. All right, can we come up with a sort of a suggested write-up?
Yeah, define different sequence.
Auxiliary sequence.
Yeah, define the other
Bn.
sequences.
Bn equals
Okay.
sigma
Nothing gives us
sigma an.
So define
And then
Bn equals
Sigma an.
sigma an. Okay. Or ai.
So many notations.
I
Can you just
equals-
use it? honestly?
yeah, and then
and then
we
the
should
squares the sum of the beats.
Oh.
CN.
wait,
So maybe the square SN is the squares.
yeah, that's an stored. Yeah,
Some of the B's.
yeah,
Oh yeah, it's one more than the yeah. So,
yeah. It's only,
so the first square is A1, B1. Okay, yeah. What's so funny?
well, yeah, it goes up to N, doesn't it? Yeah, it's just weird.
Yes.
And from
Square. Sequence of squares. And then now you go like Sn.
no, make it SNC.
Wait, the sum of the sums.
Wait,
Why
No,
is
no,
SN
no.
squared better?
Is SN squared or
Sum of the sums.
does it? How much does it matter?
Don't think it matters.
Yeah.
Because then you just say Sn is less than Sn minus 1 plus 7 or something. Oh, like.
Wait, no. SN squared basically.
Then you want to prove
I mean, that
Sn
works.
minus Sn minus
Yeah.
1
It's
is
always
less than Sn
Lesser
minus
equal.
1 minus Sn
Yeah.
minus 2.
Yeah.
Yeah. So
What's
you
these
prove
people
that.
saying?
I'm pretty sure
Yeah,
it's
yeah.
not too hard.
What do you say? What do you say? S
Sn
and
minus Sn minus 1 is less than or equal to
Yeah.
Sn minus 1 minus Sn minus 2.
Yeah.
Yeah. Equal.
Minus SN minus
Equal
2.
and
Yes.
equal. Yes.
Now we can start.
Now we can start doing.
And is it always positive? It's increasing the squares, right? Yeah.
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 So
Always
and then it's always
Oh, so it's a
positive.
decreasing sequence.
Yes.
Yeah.
Okay.
And then basically and then we know that by property of infinite descent, at least two of them will have to be the same. Basically, at least one of them will be equals for some n.
Yeah.
Yeah, and then we say if it equals,
But
Yeah,
no,
then,
always
then the rest of them.
Then the rest. Yeah. Then we can just prove the rest of them by some shenanigans.
You have to say infinite descent because it sounds.
It's so English, bro. It's not like
Sounds-
I just quote.
Don't listen to him.
It sounds cool. It's great.
No, before you know, we'll be talking about MMP.
Oh, I love,
You know,
I love that.
This is where like
MMP, bro.
he solves a problem and gets like
Oh my god.
3 out of 7 for the write-off. That's like the worst returns on brain.
Oh.
No, Lucas, don't close it. Don't close it.
wait, what? Oh, juice.
Okay, what was the idea we had before? So you had
Okay, how do we do the idea? Okay, so
you have like Sn squared plus what is it like b m plus 1 Sn squared plus b n plus a n, right? Plus 1. And then this bit here is less than it's strictly less than
Actually, no.
you say Sn plus
Show me
SN minus
Wait, there's gotta be a better way to say this.
Oh no.
That's so scuffed.
So this thing here is less than that.
How to prove
So if
that?
you plus the an, it's gotta be less than or equals.
Surely there's a better way.
That has to
Yeah.
Surely there's a better way of writing this.
Yeah, so I guess if worst comes to worst, like the final backup plan is just to say exactly what we did in general terms, yeah, and that should be a proof. But obviously, proof writing is a sort of a separate skill in that you can kind of make it the most elegant thing possible, forgetting about as much of the motivation as possible.
Alex, take notes. Do not write about motivation.
Wait, I think I have alternate idea, alternate suggestion. Right. Sn minus 1 equals
Oh, maybe yeah. Well, okay, keep going.
Sn minus 1 equals a, and then Sn equals a plus b.
Yeah.
So arithmetic sequence.
Then
Or maybe,
Sn plus 1 is less than equal to a plus 2d.
or maybe can we say this is eventually constant?
Can we say
Yeah.
that?
There we go.
If we say that's eventually constant,
Which one? Sn minus 2.
yeah, the difference. Yeah.
Yeah, the difference is eventually constant because it can't go
Right,
down.
yeah, right. Notation just to make it.
So you can make the difference like d or
That's
something.
literally
Yeah.
infinite descent, please. I
That's what you're
Man,
I think-
he just wants to say that. He just wants to say it.
I was trying to say
Once
that
it
Sn
gets
plus
you,
1
I
is
like
at
it.
most a plus 2d. Let's try to prove Sn plus 1 is at most a plus 2d.
Is a plus 2d.
Or at most.
Less than equal
Oh,
to.
we know it's less than a plus 2d. Yeah.
It's less than equal to. Because you want to show that eventually it's just the.
Oh, the actual term. Sorry. Yeah, I meant the
Like, a different might not. It might not necessarily be because it could be the same and then go down.
Oh, yeah.
Like, so at most is enough.
Yeah.
Okay, so here so we can actually even say this difference is eventually constant at d, right?
Yes.
And then we can even say that. Yeah, we can even assume they've already reached the constant stage. So then we know, like for example, Sn plus 1 is a plus 2d.
It doesn't seem
And then-
right. Wait, because you don't know it is. You haven't proven it's non-increasing yet.
Wait,
Well,
As in, you haven't proven it's non-increasing
Yeah.
yet. So you have to wait and. So you don't know what the actual D is. You know the D exists, but you can't say what the D is yet. Because it could go if you went for a
Yeah.
billion, say
And it
a
just
billion
drops,
things,
yeah.
and it just drops.
Well, I'm pretty sure we can prove
Oh, okay. So you're trying to prove that statement. Is that what you're saying? with this.
proving that the differences are not increasing.
Yeah.
Well, I guess it's
I'm pretty sure it's kind of true, but it's not. Like the difference would be.
they can do what's called
Yeah, I mean we kind of proved it already, so it's kind of like
a plus 2d squared minus a plus d squared.
yeah, it's the same thing but with notation here d, right?
Or it's same as a small case but with algebra.
Yeah, so basically we have s m plus 1, right?
It's like A and
Equals sort of s n plus b n. That's what we were writing before, yeah. Bn plus 1, which is Sn plus Bn plus Am plus 1. And now we have notation for Bn is D, right? Hold on, Sn is A plus D. Yeah, so it's Sn plus D, right? Plus An plus 1.
Something's unusual.
And then this is
Hang on.
A
Wait,
plus
isn't
2D.
Isn't this a square root? No. Wait, the
Squared,
it should
yeah.
be squared.
Oh, the squared, okay. So this s squared equals this squared plus that.
That solves one issue.
Word.
Then this is so then this is okay, so this is, let me just write that again. A plus D squared
Wait, what's D?
plus D, yeah. So D is the difference between Sn and Sn minus 1.
Oh wait, that's not right.
And then you have
that's still. I think that's still because it should be A plus B squared minus A squared.
Wait a minute.
Because the difference between squares, the difference between the previous squares is A plus B squared minus A squared.
So should this be a square? And is that what you're saying?
No. Wait, the difference in that thing down there. Wait, what am I saying? The B is
the Sn squared minus Sn minus 1.
and the Bn equals this squared minus this squared.
Yeah.
Okay, so B is not just D anymore.
Yeah, so it's A plus D. It's D times 2A plus D.
Okay, so
Anyway.
okay, yeah. So you square them.
Yes, we figured it out.
You square them and then find the difference, yeah.
Yeah.
So Bn is equal to
2AD.
Sn squared minus Sn minus 1 squared, yeah. Which is
D times 2A plus D.
yeah, D times 2A. D times 2A plus D. Yeah. Okay, then this is D times 2A plus D plus An plus 1.
So you can prove
And this
this
is
is at most A plus 2D minus 1. It's at most A plus 2D squared.
Yeah.
yeah, it's so this part is less than A plus 2D whole squared, yeah. So this part here, so this is less than.
Because it's kind of you don't know what An plus 1 is until you calculate what squares between
Squared plus An plus 1, yeah.
Wait.
See,
No, I'm pretty sure.
see, I've actually. Oh yeah,
I
I kind of have to prove it, but
don't think you need that plus A.
So this part here, so I want to show A plus D squared
We should just expand it.
plus 2AD plus D squared, yeah, is less than A plus 2D squared. It's kind of obvious if you write it like this, right?
Yeah.
Because A squared plus.
Because it's off by like 2A.
It's off
Yeah.
by D squared. Yeah. Wait. It's off by 2D squared.
Yeah, okay, that's legit. That seems legit.
Yeah? Okay, and so then An plus 1, by definition,
An plus 1 brings it up to at most
2D. A plus 2D.
that's way.
It's all coming together.
Wait a
It's all
minute.
working.
So yeah, officials, I checked the official stuff, but it had something. It looked like unnecessary, complicated thing. One thing.
yeah.
Yes.
Okay, so that shows that S that shows that Sn plus 1 is less than or equal to A plus 2D. Yeah. So then we prove the decreasing thing.
Nice.
Yeah. Then it's eventually constant. Actually, that probably just solves the problem, but you can write more to make it. You could prove a different statement, for example.
Okay.
And we show if they
Yeah.
equal and repeating. If they repeat, then you're always adding a constant term. Like an plus 1 is always
You know,
2d squared.
it would be nice to just write it all up properly, but it's kind of the value of time.
I guess this is.
This is kind of like.
Yeah.
Do you want to talk about anything else, Heather, about this?
What was I doing? I was doing a meager amount of small cases. I didn't actually read my exercise book to see.
That's such a firm believer of small cases. Small cases.
How did I?
Oh, actually, did anyone consider?
Only does the small case.
So now here's a question: when you're doing small cases, did anyone not necessarily let A1 be a square? Did you try like A1 equals 2?
Yeah, I think.
Did anyone dare to venture into that territory, or will?
I think what I did was
So I think 2 was pretty funny. Let's see. So you start with 2, you get 2 times 2, and it's a square.
Yeah, because
You have to like add 5.
Okay, next
Oh,
one.
yeah, because
And then
eventually the previous
6
numbers don't really
plus
matter.
10, and it's a square again.
So what if you
Yeah, I
allow-
remember doing this.
What if you allow numbers to be 0?
Yeah, if you allow 0,
8 plus
Wait, I think
15,
so. What's the motivation?
25,
I think.
31. So you need
Oh,
5 again.
Oh, yeah, I think I looked at the A's and then I looked at the squares themselves. So when you look at the squares themselves, you realize in order for the A's to be constant, it's equivalent somehow. So I kind of made the link and realized, oh, wait, that's equivalent to the squares themselves increasing by the same amount, and the square roots themselves increasing by the same amount. And
Or it's just 9, not just 0.
so I think that's the motivation.
Pretty sure
I think it'll be 0.
can't be 0.
Why not?
Question. I'm pretty sure it's positive integers. Not
Even if it's 0, I don't think it matters. Because after that, if it
Oh,
comes
wait,
Are there any
Next one,
questions?
next time.
yeah, next turn.
Wait, how come I don't have the polling option anymore?
Turn is like
The update.
My update took my
Isn't that
poll
more?
away.
Isn't that more? Check
Is there more?
No, the poll.
Oh, all the polls.
No,
No.
that cannot be. No.
Well, if we don't have,
apps, surely.
how will we do the 1986 Maths Olympiad without polls?
Apps.
It was held in Poland. Sorry.
Oh, I see.
Apps. Where's apps?
Apps. On right.
No,
Oh.
Next to remote control.
Yeah.
Surely. Polls.
surely.
Surely.
Well,
Wait, what?
well-
I didn't know you could do this.
What is this?
that's
What?
a different
What?
game. Surely. Boggle.
Boggle.
All right, Crystal. There was no polls, so you're just gonna have to tell us.
Wait, tell me,
We've done
what
finally
is-
killed anonymity.
what are we asking? What are you?
All right, is everything okay? Do you have any questions? Do you understand what's going on?
As if I wasn't here.
Yeah.
As if
Yeah.
I wasn't
There were different understanding
Yeah.
ratings
It
you could
turns
give.
out she was doing English as well.
here.
Oh yeah,
Is.
probably doing English.
I should be doing.
Oh, she's in the same grade as me.
Yeah.
Makes
English.
sense.
English.
English
essay.
compulsory. So yes, it would make sense.
Very likely.
Did you do extension English?
All right, if you have nothing to add to this question, you can talk about the other ones. Yeah.
Good
Oh, yes.
people. For good English people.
So, I guess it's a little bit unfortunate.
Wait for the